Hey everybody, just a little bit more to continue from the notes that you last got. C block, you've already seen some of this, so if you have, you feel free to skip this first part. So I want to start by talking about how the chain rule applies to the fundamental theorem of calculus part 2. So consider that you have some function, capital G of x, which is the integral from a to a function of x of f of t dt, where that function little g of x can be, it can be x squared, sine of x, it can be all kinds of different things. Give me 1 second. So in any case, it's not the integral from a to x. Well, if we have that situation and we still want g prime of x, we're going to have to do some manipulations. So the simplest way is to start by doing this. Let's say that a of x is what we're used to, the integral from a to x of f of t dt. Well, then we could say that g of x is just equal to a of g of x. Or in other words, plugging little g of x into that upper part of the integral of f of t dt. Well, this helps us a lot because if we want to find g prime of x, we can just take the derivative of a of little g of x. And that really is just the chain rule. So the derivative of the outside, a prime of g of x, times the derivative of the inside, g prime of x. And let's go back up here for a second. Recall that if we have a of x equals to that integral, then a prime of x is just f of x. So therefore, a prime of g of x is just f of g of x times g prime of x. So let's look at a concrete example to see how that works out. So this is example 4. So consider we have capital G of x as the integral from, the integral from -2 to x squared of sine t dt. And we're asked to find g prime of x. So this is exactly the situation that I was talking about up here. G of x is some integral from a constant to a function of x. And so here, that function of x that we're integrating to is x squared. So when we're finding g prime of x, we just plug that function in to the f of t. And our f of t in this case is sine t. So our derivative is sine x squared times, as you see over here, remember, f of g of x times g prime of x, sine of x squared times the derivative of x squared. Or in other words, 2x times sine x squared. That's our answer. A couple more examples. Let's say we're asked to find this derivative. Find the derivative of the integral from x to x plus 2 of 4t plus 1 dt. So we cannot just plug in x. We cannot just plug in x plus 2 to our function of t in the middle because it does not fit a constant to an expression of x from a to x. So what we have to do is we have to break this integral up. So this derivative, we can rewrite it as the derivative of the integral from 0 to x plus 2 of 4t plus 1 dt minus the integral from 0 to x, the 4t plus 1 dt. Think about why that's true. We've done examples where we've broken integrals up like that before, especially in our proof of the second part of the fundamental theorem. So think about how that works out. But in any case, once you've broken it up this way, it is relatively simple, because now we're asking really just to define the derivative of each piece. 0 to x plus 2, 4t plus 1 dt, minus the derivative integral from 0 to x, 4t plus 1 dt. And now we can use fundamental theorem of calculus part 2. So the first part, just we can plug in the upper bound, the x plus 2. So that is 4 times x plus 2 plus 1 minus 4 times x plus 1. Distribute 4x plus 8 plus 1 minus 4x minus 1. We just get 8. Last example. Consider we want to find the derivative of the integral from x to 5 of 3t sine t dt. Now I recommend you pause the video here and take a minute, see if you can figure it out for yourself. So notice it does not match our form, a constant to x. This is starting at x and then going to a constant. So we need to find a way to rewrite it. So the easiest way is say, well, we know that we're allowed to flip the limits if we put a negative. So negative 5 to x of 3t sine t dt. And then it is as simple as plugging in x to the function. So minus 3x sine x. And that is it. So I hope these problems are helpful in helping you to process the fundamental theorem of calculus part 2, and I hope they help you with your homework. Have a good weekend, everybody.